So in the last video, what did we do? We did partial fraction decomposition, but we didn't solve. Well, in this question here, what do we see? We see a rational function, and we are actually being asked to integrate it. Not only that, but we are being asked to definite integrate it as well. Okay, so first steps first. I noticed that the degree of the top is bigger than or equal to the degree of the bottom. This is not a proper rational. So let's get our polynomial division out here. X squared plus 3x plus 2. And what are we going to have? 3 and then 3x squared plus 9x plus 6. Subtract, we get minus 3x minus 4. So 3x squared plus 6x plus 2 over x squared plus 3x plus 2 is going to be 3. I'll say minus. I mean, technically it should be plus minus 3x minus 4 all over x squared plus 3x plus 2. I'm just going to take the minus out of the top. That just makes my life a little easier. Okay. So what can we do from there? Well, I would probably factor the denominator. It's going to be really nice this time. It's going to be x plus 1 times x plus 2. Nothing too strenuous there. So I'd probably say partial fraction or partial fraction decomposition. 3x plus 4 over x plus 1 x plus 2 is constant for each linear term. Okay. And so now, well, I need to figure out these constants here, so let's multiply both sides by x plus 1 times x plus 2. And you don't need to show me your inner workings of doing this. Basically, the bottom here is going to cancel out. This x plus 1 is going to cancel out with this x plus 1. This x plus 2 is going to cancel out with this x plus 2. And you're going to get a x plus 2, b x plus 1. Of course, don't actually cross these out when you're writing it up, because otherwise you've just covered up the work that you should be showing to us. Okay? And so, if I leave it like this, I might lose a mark. You can cross things out, just don't, completely scratch over them so no one can see what you're doing. All right, and we get ax plus 2a, bx plus b. Now, there are, really fast ways to do this if they're all linear. For example, this equation has to be true no matter what x is. So if I were to say let x be minus 1, I'll get negative 3 plus 4 here. A, and then negative 1 plus 2 is 1, plus b times 0. And so you'll see pretty quickly a is 1. Now that's a nice quick trick. But I recommend just going with the coefficients. Less things you have to worry about. Okay, so what does this tell us? A plus b is 3. 2a plus b is 4. The difference between those, so maybe it might be easier if I write it this way. 2a plus b is 4. A plus b is 3. Subtract the first equation from subtract the second equation from the first. You'll get a is 1. Plug that back in. B is 2. Okay, as long as you got the numbers right, that's likely worth the mark. But show a little bit of your work so you get everything all nice and neat. So what have we got? Well, we are finally in a position to integrate this. 6x plus 2 over x squared plus 3x plus 2. That's 3, 8, and then we've got 3 plus a, so that's 1 over x plus 1. Oh, sorry, this should be a minus. And then 2 over x plus 2. Okay. So 3 to 8 of 3 minus 3 to 8 of 1 over x plus 1. And then this minus will actually distribute, so it's another minus sign. And there should be dx's everywhere. 3 to 8, 2 over x plus 2. These ones aren't so bad. You don't have to have, say, those blocks from class memorized, as long as you can do a very quick substitution. But either way, we're going to get 3x here, 3 to 8, minus ln absolute value of x plus 1, 3 to 8, minus, I'll bring out the 2, and then ln x plus 2 in absolute value from 3 to 8. And it's just now up to me to clean things up. So 24 minus 9 minus ln of 9 minus is a plus, ln of 4 minus 2 ln of 10, and then minus, another minus is a plus, 2 ln of 5. Don't need those absolute values. And so that's 15. I didn't need the absolute values for this 4 either. And using properties of logarithms, you can put it all together. Would I leave it like this? Maybe, but we'll get 4 over 9 and 5 squared over 10 squared. I'm not going to review properties of logarithms. That's something you should know from Calc 1. 100. So we've got 25 times 4 is 100, 100, 100 here. So plus ln of 1 over 9. Because the 10 squared is 100, and that cancels, so it's going to be ln of 1 over 9. Or you can just say 15 minus ln 9. I think that's probably the cleanest answer. And there we go. And that finishes up question number 5. Up next, of course, question number 6.